their very existence too soon after the dawn of time. It was as though the universe was operating on a script that had never been shared with us. Galaxies were not supposed to be that advanced so early. These weren't just clearer pictures, they were glimpses into the ancient past, further back in time than any instrument had ever managed. But what Webb found were massive, organized galaxies already in place just 300 to 400 million years after the supposed beginning of time. Some of them were larger and more structured than our Milky Way. This was not the cosmic baby photoscientists were expecting. It was as if the foundation of the universe had been laid long before the blueprints were even supposed to exist. One particular galaxy, labeled CER 93316, became the epicenter of this shock. Its extreme redshift indicates it formed at a time when, according to our best equations, no galaxy should exist. Yet there it was, fully formed, glowing, spinning. Its presence alone called into question our entire timeline of cosmic evolution. If galaxies were this mature so early, then the timeline of expansion, cooling, and structure formation wasn't just slightly off, it was fundamentally broken. The uncomfortable implication was that either the universe built itself impossibly fast, or that it didn't build at all. That perhaps it had simply been there fully formed, waiting to be discovered. But Webb's revelations didn't stop with ancient galaxies. What it showed next was even more unsettling, a flaw embedded deep within the fabric of space itself. The architecture of the cosmos, as we understand it, should emerge slowly. Particles become atoms, atoms form gas clouds, which eventually ignite into stars. These stars gather into galaxies, which, over billions of years, link into clusters and then into massive cosmic webs. But Webb has detected massive, interconnected galactic structures, hyperstructures, that shouldn't exist so soon in the universe's history. These weren't observational errors. They were verified through repeated measurements, spanning wide regions of space. And the math simply doesn't work. The time required to build such colossal systems is far longer than the universe is supposed to have existed at that point. Dr. Garth Illingworth, an astronomer studying Webb's findings, put it plainly. We're seeing systems that need twice the age of the universe to form. This raises two possibilities, both of them alarming. Either our understanding of gravity, the force that supposedly shaped the cosmos, is flawed, or something unknown is guiding this structure formation. Dark matter, the invisible scaffolding assumed to glue galaxies together, has failed to appear where expected. If these hyperstructures formed without its aid, then dark matter may not be what we thought, or may not exist at all. Some physicists have started to float an even more radical idea. Gravity itself might behave differently in different eras or regions of the cosmos. That the laws we observe today might be local phenomena, not universal truths. If this is correct, then our universe isn't a single, uniform system. It's more like a patchwork of realities, each governed by slightly different rules. The implications are staggering. It means the universe might be less a machine and more an organism, shifting, adapting, playing by rules we haven't even begun to comprehend. A long-standing mystery in cosmology known as the Hubble tension, the disagreement between measurements of the universe's current expansion rate and its earlier rate, was something Webb was expected to resolve. Instead, it has intensified the problem. Observations based on the cosmic microwave background suggest one rate of expansion, while measurements using supernovae and galaxies suggest another, faster one. Webb's precise data supports both, making the contradiction undeniable and impossible to dismiss. This has led some scientists to drop the term tension altogether. They now call it a crisis. Perhaps the universe isn't expanding at a constant rate. Maybe different regions stretch at different speeds. Or perhaps, even more disorienting, we are no longer observing from a stable frame of reference at all. It raises the possibility of a cosmic drift, where space-time itself may be slipping or evolving in ways we don't yet understand. There could be phases of expansion, multiple dimensions interleaving, or even secondary inflation events that occurred after the Big Bang, none of which are accounted for in current physics. Even the most sacred proof of the Big Bang, the cosmic microwave background, is being questioned. This faint glow, believed to be the first light ever emitted in the universe, was long considered the fingerprint of creation. But Webb's data challenges this assumption. Its ultra-sensitive instruments have found that dense clusters of early stars can generate light so intense and redshifted that it closely mimics the signature of the microwave background. If that's the case, then the signal we've trusted for decades may not be a pure echo from the birth of time. It may be a false trail, an illusion created by overlapping emissions from countless early galaxies. If this is true, then the Big Bang might not be the beginning at all. It might be a transitional event, the flicker of a new phase born from something even older. It could be a reboot, a cosmic rearrangement, or the aftermath of a process that predates all known physics. That's a chilling thought. Because it means we haven't discovered the beginning of everything. We've only peeled back a veil, and what lies beyond that veil may be something so alien, so far outside our understanding, that none of our tools, none of our laws, can penetrate it. These weren't simply filaments or tendrils of the cosmic web. They were arrangements, geometries. The kind one might associate with design. It's a controversial suggestion, of course. But it's gaining traction among those who can no longer ignore the sheer improbability of what Webb is revealing. If the early universe looks planned, if it appears built, then the conversation changes from one of physics to one of purpose. And science, for all its rigor, there are moments when science pushes too far, when the curtain of the universe is pulled back just enough to reveal something we weren't ready for. That's what the James Webb Space Telescope seems to have done. Not with dramatic explosions or catastrophic events, but through patterns, subtle, persistent, and deeply unnerving patterns. In the vast tapestry of galaxies, certain alignments began to emerge. Not random, not chaotic, but precise. Resonant structures began to appear, as if space itself hummed with harmonics. These weren't isolated anomalies. Entire clusters of galaxies, separated by billions of light-years, mirrored each other with geometric regularity, angles, arcs, intervals that echoed across the void. To some scientists, this pointed to a disturbing possibility. The universe might exhibit crystalline behavior on a grand scale. That shattered a foundational assumption of cosmology, that order emerges from chaos over time. Instead, it hinted at a deep structure, a hidden blueprint not born of randomness or gravity, but of some unknown rule embedded in reality itself. A rule we didn't write. And if the symmetry is real, then one question rises above all others. Is the universe a natural consequence of physics, or something that was built? This unsettling possibility gained even more weight with the discovery of a repeating signal, something that defied every model of how light and space should behave. While observing a gravitational lensing phenomenon, where light from distant galaxies is bent around massive objects, Webb recorded fluctuations in brightness that were nearly identical, occurring in ways statistically impossible to be random. Initially dismissed as a glitch, this repetition held up under intense scrutiny. It wasn't noise. It was a mirror, echoing the same cosmic patterns billions of light-years apart. This suggested a possibility no one wanted to consider, that light might be caught in a loop. Not just bending around matter, but navigating a topology of space far stranger than any map we've drawn. That raises a chilling thought. What if the universe isn't the open, endless expanse we believe it to be? What if it's more like a membrane, curved, finite, and folded? A place where light reflects, repeats, and replays, where reality is like a hall of mirrors and what we see is both real and its own echo. A holographic chamber masquerading as infinite space. Yet not all of Webb's revelations were loud. One of the most disturbing came from silence. As it scanned a seemingly empty region between two massive galaxy clusters, Webb recorded something odd, a void. Voids are expected in the cosmos, but this one wasn't like the rest. It was too cold, too silent, too perfect. The edges were unnaturally sharp. The temperature drop was smooth and absolute. And most disturbingly, detectors aboard other instruments in the area noticed something quantum physicists found deeply unsettling: an absence of virtual particle interactions. No blips. No foam. No energy fluctuations. It was as if a patch of space had been erased. Not empty, erased. Some began calling it a quantum scar, a region where physics may have broken down entirely or rebooted after a colossal event we can't even begin to imagine. Others proposed it's a kind of firewall, a boundary of the universe where information is not just lost, but deliberately hidden. The most terrifying idea is the simplest, that this part of the universe has been cut out. Not by nature. Not by entropy. But deliberately removed, like deleting a frame from a film reel. But the fear doesn't just come from what Webb has seen. It's coming from what those observations are doing. Across numerous research teams, a disturbing pattern is beginning to form. The deeper we look into specific regions of space, the more unstable our models become. Constants drift. Equations that once held true begin to wobble. Physical laws bend ever so slightly away from their expected paths. A term once reserved for philosophical debates is now quietly appearing in academic papers: the cosmic observer effect. The idea that observing the universe at this depth might actually change it. What if space-time isn't passive? What if it's reactive? If our most sensitive instruments are not just capturing data, but influencing the system they're studying? That would mean the act of observing, of attempting to understand the universe's origin, is altering it. That perhaps, like a complex system with built-in safeguards, the universe responds to intrusion, not with violence but with distortion. With concealment. With misdirection. It's no longer just a question of whether our models are wrong. It's whether we've crossed a boundary we weren't meant to. A threshold not of distance or energy but of permission. The more we stare, the more reality seems to twitch. As if something doesn't want to be found. What began as a mission to see the first galaxies has turned into something far greater, far stranger, a confrontation with a universe that may not be indifferent, but aware. Now, our constants aren't constant. Galaxies exist where they shouldn't. Time behaves in ways our equations can't explain. And light itself, once our most trusted guide, now appears to be playing tricks, looping back, echoing patterns, and perhaps, reacting. We thought the Big Bang was the beginning. But what if it was only the most recent ripple in a much older ocean? What if everything we've discovered is only the surface of something deeper, and we've only just begun to peel back the layer hiding what lies beneath? There's a growing unease among physicists, not about what we know, but what we've accidentally stumbled upon. The universe we believed was cold, mechanical, and comprehensible is now showing signs of depth, of design, of something more. Something possibly ancient, maybe even intentional. As if there's a script running beneath reality, and we've read a line we weren't meant to find. So what has the James Webb Space Telescope really uncovered? Are we rewriting the laws of physics, or simply peeling away a layer of reality we were never meant to see? The answers are no longer just scientific, they are existential. The cosmos has never been more beautiful, nor more terrifying.